Hi everyone. So in this lecture, I want to continue on program control instruction. The third program control instruction that can alter and change the sequence of the wrong execution is subroutine instructions. Using subroutines, we can have a group of instructions outside of the main program, and we can call them whenever they are needed. You can see them here. So we have a main program, and then we have a subroutine program. So this subroutine is a group of instruction which is outside of our main program. And if a sequence of wrongs is supposed to be repeated numerous times, it is good that we program them one time as a subroutine, and then whenever we need them, we can call this particular part of program, which we are considering that as a subroutine. And remember that the variable data are permitted to be used within our subroutine, and they can be overridden by the subroutine as well. Three different instructions are involved in a subroutine: JSR, SPR, and RET. JSR is jump to subroutine, and it is an output instruction. SPR will be used at the beginning of a subroutine, and it's an input instruction. And finally, RET is an instruction that we need to have in order to finish the subroutine program. So we need at least one RET at the end of each subroutine. And RET instruction is also an output instruction. Okay, so these are three different instructions involved in a subroutine. Now let's talk about them in more detail and see how we need to use these three instructions. The first one, which is JSR, basically tells us when we need to jump into our subroutine. So whenever we have a JSR in our program, then the program will look at the condition of JSR. JSR is an output, so it has a condition that you can see here. If the condition brings continuity, so if it's true, then JSR is active, and whenever JSR is active, the program will jump into subroutine. So let's look at how the program will be executed. The program will be started from the beginning, and it reaches to this particular wrong. At this point, because JSR is active, so we have continuity over this instruction, then it will jump to SPR, which is used at the beginning of the subroutine program. Then the wrong within the subroutine will be executed. So this part of program will be executed, and as soon as we reach to a return, which is unconditional, then the program will jump to the line after JSR. So this is how the program will be executed. It will be started from the beginning. It will reach to JSR, which is active. Because it's active, it will jump to SPR, which is the start of our subroutine. The subroutine will be executed until we reach to the return. When the unconditional return is executed, then the scanner will go back to the wrong after JSR wrong. So we are not going to go back to the same wrong, because in that scenario, an infinite loop will happen and we'll be stuck in a loop. Something to notice about RET, which is our return instruction, is that we need to have at least one unconditional return in subroutine. So the very last wrong of our subroutine, which is the one we have here, needs to be unconditional. So it means that at the end, we can go back to the main program. So this is a necessary wrong that you need to have in your subroutine. But you might want to use more than one return. So for example, you're allowed to have another return somewhere here, and you can put a constraint here. For example, if this particular input is true, so if you have continuity over this instruction, then your return will be activated, and then at this point you can go back to your main program, the rung that is after JSR. So if the condition is satisfied, then the return happens right away. If it's not satisfied, it will go to the next rung in the subroutine. But the reason that you need an unconditional return at the end is that you want to make sure that if none of your returns, none of your conditional returns are satisfied, then you have one unconditional which can bring you back to the main program. Okay, now let's look at the nesting concept here. Nesting subroutine allows us to direct the flow to a subroutine, then another subroutine, then another one, without returning to the main program directly. So you can see that here, this is our main program. In our main program, we have a jump, and this jump is referring to subroutine which is located in file 7. So the program will be executed here up to this rung. Assuming that this jump is activated, then the program will jump to subroutine which is located at file 7. Now within this subroutine, we are allowed to have another jump. So a jump inside a subroutine, what can do is that it can redirect the flow of the program into another subroutine without directly coming back to the main program. So here the program will be executed until we reach to the subroutine jump. So if this subroutine jump is active, the scanner will jump to file 8, which has another subroutine, and you can see that here. So it will jump here, and again it will continue executing the file until it reaches to another jump, which is redirecting the program into file 9, and this can continue, and at the end there would be a return that can return us to the main program. So something to remember, that this nesting subroutine can affect the scanning rate significantly, and it may cause input and output not to be evaluated at the required time. So it can make the scanning time so long that the data that you need to constantly update remain unupdated, and it makes some problem for your application. Now let's see how we can set up a subroutine. So if you go to the left hand side of your software, then you have this program file. In program file, you have something like this ladder 2. This ladder 2 is referring to your main program. So this is your main program. Now, if you want to make a subroutine, you have to right click, and then you have to add a new ladder, and in this new ladder you need to assign a number. So for example, you can see the number is 3. So whenever you hit OK here, you're going to have another ladder, which is ladder 3, and this ladder 3 is going to be a subroutine. So ladder 2 is always your main program, and then by adding more ladder into your program file, you can have subroutines. This is how you can address to your subroutine. You need this addressing format. So U:3 or U:4 up to U:255. So each one of these are addressing to one subroutine. So if you are using 3 here and you want to address to this ladder 3, then the address you have to use is U:3. Okay, and my last comment is about JSR configuration. So how we can use JSR in our program. So we have two different approaches of using JSR. The first one is unconditional, which means we have an input wrong, which is always true, and this is connected to a JSR, and this JSR will send the scanner to the subroutine, which has the address of u colon whatever number we have here, for example u colon 3. So when the scanner reaches to this wrong of the program, it will be sent to a subroutine, which we have the address of the subroutine here, and it's u colon 3, for example. So this type of unconditional subroutines are appropriate for dividing a large program to logical segments for easier development and maintenance situation. But the next one is controlled subroutine. So the second approach of using JSR is controlled subroutine. So it means that we have a constraint in order to activate our JSR instruction. And this is the most frequent type of using JSR. So it depends on the condition of a particular input instruction. We can decide if we need to go to the subroutine and execute the subroutine, or we have to continue to the next rung.